Hello Year 7 and welcome to Rounding, Recurring and Terminating Decimals. Let's get started first of all just with a little bit of practice rounding off. So I'd like you to round off 17,236 to the nearest 10, 100, 1,000 and 10,000. Please pause the video and have a go at that now. Okay, so I hope you're done and you've got your answers there. Let's check them. So to the nearest 10 we get 17,240, the nearest 100 we get 17,200, and the nearest 1,000 I get 17,000, and the nearest 10,000 I get 20,000. Note that I can't round it off to the nearest 100,000 because then I'd have to round the whole thing down to 0, and we don't round things all the way down to 0. And you might be wondering, well, what's this I'm writing here? 4 significant figures, 3 significant figures, 2 significant figures, and 1 significant figure. Significant figures are the numbers that I didn't replace with 0. So in this, I've replaced the 6 with the 0. The first one I've replaced the 6 with the 0, but the 1, the 7, the 2, and the 4, I haven't just cancelled out and replaced with zeros. Even though I've rounded the 3 up to 4, we still say that this last one's the only one I've truly rounded off because I've replaced it with a 0. And you can see here there are 3 numbers or 3 digits I didn't replace with zeros. Here there's 2 digits I didn't replace with zeros. And here there's only 1 digit I didn't replace with 0. So this has 1 significant figure. And notice also I still have to write these zeros in here. When I round off 17,236 to the nearest 10,000, I have to write 20,000. I can't just write the 2, that'd be silly because 17,236 doesn't round off to 2. I need to write these zeros here to tell me which one is in the tens column, which is in the ones column, which is in the hundreds column, and so on and so on. And all these zeros tell me that this 2 is in the 10,000ths column. It's not in the ones column or the tens column. There are 10,000 twos, and I've got 20,000 when I'm rounding off 17,236. So I have to write these zeros to tell me which column everything's in. And that's very important because when we round off decimals, it'll be a little bit different. Speaking of rounding off decimals, round off 21.372 to the nearest 100th, 10th, 1 and 10. Pause the video and have a go at that. Okay, let's hope you're done. So your solutions are 21.37, 21.4, 21 and 20. But something a bit different's happened here. I haven't written 21.370. This 2 here, I didn't need to change to a 0. The reason I didn't need to change it to a 0 is because I've already got this decimal point here. This decimal point tells me that this is the tens, this is the ones, this is the tenths, and this is the hundredths. So I don't need to put all of those extra zeros on at the end, so all the digits keep their place value, like I did in the last example. And same with this one here, 21.4. I don't need to write any numbers here. I don't need to write 00 here because the decimal point is doing the work of all those zeros at the end, telling me that this is 4/10ths. Okay, so when I round off numbers after a decimal place, instead of putting a whole bunch of zeros like I do when I'm rounding off whole numbers, I can just not write them. And when you do your work in Year 9 on significant figures, this is a very important concept to understand. Okay, so now we've had a look at rounding, let's do the next question. I'm going to ask you to write 1/8 as a decimal. It's a bit of revision, but let's do it anyway. Pause the video and have a go at it. Okay, I hope you're done, and I hope you got, you divide 8 here, and you've got 1.000, and you wind up with 0.125. Should be pretty easy. 8 doesn't go into 1, it goes into 10, once with 2 remainder, goes into 20, twice with 4 remainder, and it goes into 45 times. So you get 0.125. Nice and easy. And notice that after 8 goes into 40, exactly 5 times, I stop dividing. Compare it to this next one. So now I want you to write 1/7 as a decimal. So pause the video, and you may have the video paused for a while because you're going to find this one takes a lot longer to do. Okay, so I hope you've unpaused the video now and you're back. You might have spent a bit of time working on this. So let's have a look at the answer. I'm guessing you did something like this. You went 7 here, and then you did 1 point, and you put down all your zeros, and you worked this out, and you got 0.1428571. And then when you got to this 1, you probably realized you were getting that same pattern again, 142,857, and it just went on, and you probably got sick of dividing after a while. So let's have a look at how we can write this. We've got 1/7, and I can write it like this, 0.142857, and a line above it means that all of this stuff repeats forever. I could write it with dots above all the numbers, and all the numbers with dots above it repeat forever. And I could write it like this, 1 dot here and 1 dot here, and all the numbers between the dots repeat forever, okay? So these are all 3 ways of writing the same thing, which is just this number that goes on forever and ever. Alright, so let's just see if we've got the hang of it. We've got these, and I want you to write these repeating decimals out. So I want you to write it out as 0.2, and I just want you to write a bunch of the repeating decimals, maybe 5 or 6 of them. Okay, so I'm hoping that you've paused the video. If not, pause it now and do these questions. Alright, good. I hope you've done. Let's check our answers. So 0.23 with a little dot above the 3 means 0.23333333, and so on and so on. Only the 3's repeating here. 1.257 with the dots above the 2 and the 5 mean we repeat everything in between them, okay? So it means we're repeating 1.257257257. It doesn't mean we repeat 1.257272727. This whole part here repeats. And the next one was 7.356. So I hope you got it's 7.3, 456, 456, 456, and so on and so on. Okay, so have a look at that, and I hope you're happy with that. Next question, and it's a little bit of an algebra one. I want you to write 0.7, and that's 7 repeater, as a fraction. Bit of a tricky question, so pause the video and see if you can work out a way to do it. Okay, I hope you're back and you've got your solution, or at least what you think your solution is. And let's check my solution. So I used a little bit of algebra. I said, let's let x equal to 0.7 dot forever and ever, 77777, and I multiplied it by 10. So I said, if x equals to 0.77777, 10x equals to 7.7777777, and so on. And then I subtracted them, so I go, okay, if I get 10x minus x, I get 9x. But if I get 7.77777 and I take away 0.77777, well, just doing our regular old subtractions, we can see all of these 7's here are going to cancel out with each other, and we're left with 9x equals to 7, and divide both sides by 9, and we get x equals to 7/9. As a fun little exercise, and I'll let you do this one and tell me the answers in the comments, tell me what you think 0.9 repeaters are going to be equal to. I think you'll be very, very surprised when you find out what this equals to. Okay, guys, that's it. So let's now have a look at our homework, and we are going to be working on Cambridge 8 for E, all of question 1, all of question 2, then the questions from 5 to 10 and every second part of those, so A, C, E, and so on and so on. That means A, C, E, G, I, K, and so on until you can't do any more because you run out of questions. And then question 11, question 12, and 14. Okay, guys, thank you very much, and I will see you in the next video.